Alright, let me get some. Bum, 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 bum. Alright, let me mute this. What's up? How do I mute notification? Always. just watched some videos just when I had my lunch. That's when I'm chilling. What will we check out? Why NASA is getting crushed in terms. Yeah, let's watch this. Let me change scene. Nice. T.
NASA is the American space giant responsible for sending people to space for decades and even putting people on the moon. The rich history and sky-high accomplishments of NASA are known around the world today. But for the last couple...
I mean, just before we get into it, like, I think one of the reasons, like, they're kind of constrained by what the government wants them to do, because it's a government enterprise, it's not private. So, like, the main answer I would imagine they're going to argue is that they don't have as much freedom. And if you don't have as much freedom, you can't innovate as much. Because to innovate, you kind of have to push against the norms, go outside the box. So it makes sense that they're getting crushed in innovation. I don't know what you can do about it, to be honest. Yeah, I mean, you can just give them a little bit more leeway, but then you run the risk of, like, how much you give big corporation. Well, I don't even know if you would call them a corporation, but you get my point. Yeah, let's see what they have to say.
Couple of decades, it seems like NASA has hit a plateau in terms of innovation and advancement. They've contracted out several tremendous tasks to private companies like SpaceX, Blue Origin, and Rocket Lab. Meanwhile, they've been working on something called the Space Launch System, which seems to be extremely expensive, especially in comparison to the competition. So, what happened to NASA? Well, starting off, one of the first tasks that NASA didn't do so hot in was of course the Space Shuttle. The Space Shuttle was an extremely ambitious program, and many of its goals were achieved. For instance, the Space Shuttle boasts a massive payload capacity of 29,000 kilograms. To put that in perspective, the Falcon 9's payload capacity to low Earth orbit is 22,800 kilograms, and that was developed decades later. Aside from this, the Space Shuttle would play an integral role in the construction of the International Space Station, as it was the only rocket ship at the time that was capable of carrying many of its parts. Evidently, the Space Shuttle was quite an important development. However, it failed at some of its core goals, such as providing reliable rocket reusability and reducing the cost of spaceflight. The Space Shuttle was reusable.
I do.
But this
New
didn't
glasses,
really help
man.
much. Till very recently, the Space Shuttle held the record for the fastest turnaround.
Yeah, it's just I think I started using this new toothpaste,
when it comes to the
and it's like really bringing out my smile a bit more, I think.
It wasn't the turnaround
I think that must
was
be
the
it.
biggest problem. The real killer was the cost of reusing the Space Shuttle. At the end of the day, the NASA Space Shuttle program cost a massive $209 billion, which allowed for 135 flights. That's the same as $1.55 billion per flight.
Well, I missed that. Let me go back.
Constructing 135 space shuttles.
That seemed like a big number.
The biggest problem. The real killer was the cost of reusing the Space Shuttle. At the end of the day, the NASA Space Shuttle program cost a massive $209 billion, which allowed...
To put that in perspective, I think that to land on the moon it cost 30 billion. I could be wrong, but I think it was 30 billion. That might be in old money. I don't know what the comparison is. We can check out after this. But like, that's a whopper number, like 209 billion. Jesus. But yeah, I mean, you have to, like this many flights is insane. And I think that 30 billion I mentioned, I think that takes into account all the different Apollo missions as well. Not just, was it Apollo 11 or Apollo 9 is the one that landed, I forget. But it wasn't just the one landing that cost 30 billion, it was the whole program as well.
That's the same as $1.55 billion per flight. At that rate, constructing 135 space shuttles may have come out to about the same price. NASA was well aware of this massive shortfall, and this is one of the main reasons they stopped the space shuttle program. Though it was unfortunate that this decision would strip America of being able to launch astronauts to space from American soil, this allowed NASA to get a clean slate and start over. This decision would lead them to start development of the Space Launch System, but the news so far about this is not very promising. In fact, NASA themselves estimate that a single launch of the Space Launch System will cost up to $2 billion.
Wow.
And that's not even including development costs. Meanwhile, SpaceX's upcoming Starship rocket.
I thought that SLS was reusable. So I wonder if that takes into account the reusability as well. If so, like that's a fucking insane number.
Capacity, but it also costs significantly less. SpaceX is hoping to bring down the cost of Starship launches down to just $2 million. But even if they underestimated the amount by 100x, a Starship launch will only cost a tenth of the price of an SLS launch. As you can see,
that's insane.
NASA is not nearly as innovative today as they were during the Apollo days. But why? Well, unfortunately, in my opinion, the primary reason NASA has stalled for so long is politics.
Yeah.
NASA is a government organization and is funded by taxpayer dollars. As a result,
it constrains them.
Congress have significant control over an organization that they usually don't even have a very good understanding about. Moreover, even if they do have a solid science background, it's likely that politicians will favor funding organizations and programs that will help them get re-elected, as opposed to organizations that have waning interest. The truth is, even though NASA is an extremely important organization helping us travel and colonize beyond our own planet, public interest in space has been waning since the moon landing. You see, during the 1960s and 1970s, space exploration was a sense of pride for the average American, as tensions regarding the Cold War were at a peak. As a result, politicians were extremely willing to fund NASA, as that helped them garner massive public support. Once America won the space race, though, by placing people on the moon, the average American's interest in space exploration quickly dwindled away. For them, reaching the moon as JFK envisioned was the climax. And the next major space event that would get the average person riled up again was reaching Mars. Though improving rocket reusability and setting up a space station would lay the foundation for eventually reaching Mars, these weren't the most exciting of tasks, and so the average person slowly lost interest. In fact, a poll conducted in 2018 revealed that only 37.9% of respondents thought that returning to the moon is a priority right now. 42.9% straight up said that it's not a priority.
I mean, let's look at this for a second. Like, what does priority mean, you know? Like, is it that you have to drop every single thing else and do it? Or is it like it's a priority in like a space exploration front? Because even if it is the second one, like some people might be like, oh no, going to the moon is a priority, or no, like getting more satellites into space to observe Earth is more of a priority, you know? Realistically, they're all like kind of equalish in the advantages you get from those sort of missions. But the wording is just a bit off to me. I'd have to look at, I don't know, like to see what their reasoning was a bit more. Because like I can see a lot of reasons as to why it wouldn't be a priority, but it would still be pretty important to do.
18.2% responded that NASA should focus on sending robots. Given this sentiment, NASA's funding has slowly been cut. If you simply look up NASA's funding figures over the years,
and this is all public,
the overall trend is clearly upwards. However, this doesn't account for inflation. After accounting for inflation, you'll see that in the late 1960s, NASA received a solid $40 billion annually in funding. Today, nearly 50 years later, they only receive half of that at $20 billion annually. Moreover, during the same time period, the American GDP has skyrocketed, meaning that the tax revenue has also skyrocketed. As a result, not only has NASA's actual funding itself gone down, but so has the percentage of tax revenue that NASA receives. In the 1960s, NASA was receiving up to 4% of the total tax revenue. By 2015, though, this number had tanked to just 0.5%. Aside from poor funding, NASA has to get approval from Congress for the structuring of their budget every year, which gives NASA very little flexibility as to how they spend their funding. This wouldn't be that big of a deal if there was a congruent goal amongst politicians, but this has not been the case whatsoever.
By the way, this is why I think the fact that Russia and China are teaming up is really good, because if Russia and China are working together, then that means that American politicians will be motivated to try and like outdo them, as has happened in the history with the moon landings. So although America and NASA have lost like an ally, I think it's actually really good because it'll motivate them to put more money into NASA. They don't need like an ally, because realistically all the ally is doing is picking up the slack where they don't want to spend the money on. Now when they see that they have a bit of a competition going on, they're motivated to like pump in money then and try and like level the playing field in a way, which is really good. It doesn't really matter who wins. All that matters is that like kind of innovation is made and kind of cool things happen, you know. So like what it is a bit of a sack, I think it's really motivating for sure.
For instance, just take a look at the proposed plans over the past 20 years. In 2004, the Bush administration would come up with the Constellation program. This program was supposed to put NASA on the pathway to retiring the space shuttle program and reaching the moon. The plan called for the development of a rocket called Ares and a spaceship called Orion. NASA would quickly get to work on this plan, spending over $9 billion over the next couple of years on research and development. After President Obama took office, though, he would scrap the Constellation program and instead approve the SLS program. This means that the $9 billion that NASA spent on the Constellation program was basically a complete waste. Aside from this, Obama would also change the focus of NASA from returning to the moon to launching astronauts to Mars and asteroids. But just as this plan was settling in, President Trump would come in and shift the focus of NASA back to the moon. Business Insider estimates that this constant switching of plans from one president to the next has cost taxpayers $20 billion in just the last 3 administrations. In addition to the wasted resources on each scrap, the constant changing of goals no doubt prevents momentum from building up, making it difficult for NASA to make any real progress. Aside from these various political games, NASA has also suffered from an aging workforce. Astronaut Harrison Schmitt points out that the average age of mission control during the Apollo days was just 26 years old.
Nowadays, probably
Today,
50,
the average
40.
age of a NASA employee is closer to 60.
What?
Evidently, NASA hasn't been that attractive for the younger generations. In the mid-1900s, one of the most common dreams for kids was becoming an astronaut. However, over the past 50 years, so many interesting opportunities aside from space have come to fruition with the help of technology. Many kids nowadays want to become YouTubers and gamers and entrepreneurs. The percentage of kids who want to become astronauts when they grow up is definitely not as high as it used to be. Moreover,
I don't know about that. I don't know if there's many like 4-year-old or 5-year-old kids saying that they want to be an entrepreneur anymore, or at the moment. I'd be surprised. I can see how there be some that want to be professional gamers. I know when I was 5 years old, I really liked playing games, but there was no like professional gaming wasn't mainstream at all. So that thought never occurred to me. But if I was 5 now, I probably would think that that'd be like a dream to do. Right? I guess I haven't talked to any young children to see what if they want to be an astronaut or not, you know. But I remember when I was young, like it'd be like, oh, I want to be Superman, I want to be an astronaut, I want to be a fireman, whatever. It was always the standard stuff. But what this guy said, entrepreneur, gamer, and YouTuber. YouTuber's an interesting one. I guess it's the same as being like, you know, when I was younger, maybe you'd like, oh, you want to be an actor or a movie star. Because you used to watch that sort of stuff that you want to be in them, right? But these days, a lot of kids would be like on their parents' phones or on the computer or the iPad, and they'd be watching a lot of YouTube and kind of having the point that they would want to be those people. So that also makes sense to me as well, to be fair. But entrepreneur less so, because I don't think that young children are consuming entrepreneurial content. I think if you get into the teenage years, like if you're kind of in high school or secondary school or whatever you want to say, I think then that becomes a little bit prevalent. But like when I was younger, I don't think there was anyone 14, 15-year-old age bracket when I was that age that were still saying they want to be astronauts. That's a young thing. That's like age 3 to 8, even a little bit older, maybe like 4 to 8. But entrepreneur, I'm not too sold on that.
for kids that do want to become astronauts or work in the space industry, NASA is not generally their first choice. SpaceX is. Kids today grow up watching SpaceX landing their boosters and sending a roadster to space and working on reaching Mars. This is further accelerated by Elon Musk's clever use of social media. Every time SpaceX completes a mission, whether successfully or unsuccessfully, you can bet that Elon will be posting the results to his 43.2 million Twitter followers. As a result, young adults don't want to go work at NASA where things really haven't moved for decades. They want to go work at SpaceX with Elon Musk. And that brings me on to my final point. which is that NASA themselves have become self-aware of their shortcomings. Given that NASA has been around for over 60 years, their leaders have come to the realization that NASA is limited by government funding, declining public interest, and an aging workforce. Thus, they have decided to embrace commercial spaceflight themselves. NASA Administrator Jim Bridenstine has placed a heavy focus on using NASA funding to fund SpaceX, Blue Origin, and Boeing, as the money will likely have a larger impact in the free market. The number of commercial spaceflight customers is quite limited, and NASA is no doubt one of the biggest customers, if not the biggest.
Of SpaceX.
They've decided that promoting competition within the commercial spaceflight industry is the best way they can spend their money. At the end of the day, NASA is the pioneer of space travel and exploration. Over the years, they've continuously tried to push the envelope, but have often failed due to a variety of external forces they have no control over. Considering this, they've decided to fund private companies that don't have the same restrictions that NASA does. And while they continue to work on programs like SLS, I have a feeling that their main focus right now is working with private companies to revolutionize the future of space travel and colonization. What do you guys think is the main reason for the declining innovation from NASA? Comment that down below. Also, drop a like if you guys thought this video explained NASA's obstacles well. And of course, consider joining our Discord community to suggest future video ideas, and consider subscribing to see more questions logically answered. But until then, I'm Hari, and I'll see you guys on the next one.
That was a nice video. I'm gonna sub to this dude. Alright, let's get some music. Almost finished my food. Let's go do a little sound test. Oh, it's fine. This new mic has been really nice. Sounds are the levels are always fine, but with my old mic, I never got the mixer right. Never. What did I want to do again? I want to check some new mic. I want to check. Oh yes, headliner one. Excuse me. Oh, excuse me. Okay. Open up to the page. Okay, 1st of April is fine. I'll do it wrong. Okay. So what's the story? I guess I'll continue on from where I was yesterday. Okay, so let's just get the OneNote up. And we're gonna change the scene. Okay, let's go, boys. Right, so I'm just gonna put my notes over on this screen. We're gonna see whereabouts I got to. Oh, I wouldn't mind checking Teams as well. So again, I'm not too happy with the wording of a lot of this stuff. I think I make it look nicer. But as I said, I just want to get the content down, and then I can worry about like making it look nicer later on. So okay, make a line here. What am I doing? Okay, get chat on my phone. I kind of want the more boppy. There was a really boppy playlist I had the last day. I really like this though, so I'll come back to this later on. But yeah, I want to kind of fuck with that one for a while. So let's see, YouTube. I'm checking out here. Okay, well maybe if I control H this. And look up copyright. Yeah. Hey, there we go. let's get this going. So I'm gonna put on the main screen. I want the Mars document for sure, so let's get this up. So let's see, where did I get to here? There are a couple ideas. Firstly, it could be biological origin. This could be from microorganisms which are now long extinct, but the methane that those organisms produced was trapped in the subsurface of Mars. So we're actually gonna straight away, I don't want that sentence getting too long. Alternatively, it could be from living microorganisms. The methane. Okay, so yeah. The methane could also be geological. Yeah, I don't know. I'm gonna have to really go through these words again. Alternatively, it could be the methane could also be geological through a process called serpentinization. This is a process by which olivine reacts with, I think it's serpentine. But yeah, let's get this going. So, what I'm looking up, serpentinization. Let's go to the main wiki. This is serpentinite. Minerals in this group, which are rich in magnesium and water, light to dark green, greasy looking and slippery feeling, are formed by serpentinization, a hydration and metamorphic transformation of ultramafic rock. So I think that olivine is ultramafic. So that would be the olivine here from the Earth's mantle. The mineral alteration is particularly important at the seafloor at tectonic plate boundaries. Okay. So this is the process by which olivine reacts with a serpentinite rock, or maybe a mineral. Let's just say a rock. A mineral that is rich in magnesium and water. No, that's wrong. This is a process by which olivine reacts with a serpentinite rock. I need the chemical reaction, it should be here. I want the chemical reaction with CH4 getting on the phone. Here, this one. So you have olivine plus water plus CO2 gives you serpentinite. Okay, so I made a slight mistake here. So first of all, I'm gonna do a chain bracket and be like, in latex, include the chemical equation, reaction 2A on serpentinite wiki. Alright, close that shit. The methane could also be geological through a process called serpentinization. So I include the reaction, which is reaction 2A. I just leave it at that, I think. I just explain what each one is. But like I'm showing that with olivine and you add in water and CO2, you get serpentinite and you get methane. So it could be inferred that if you find serpentinite, there might be some methane going on too. Okay, where was I? Okay, so I kind of want to get away from methane now. I think I've done enough. Okay, so I've let's see what I've done. Okay, so there's a discrepancy between what satellites are observing and what rovers are observing, which begs the question: can we use an instrument in an intermediate level to get more reliable results? That's all that's happening here. So then, because we're specifically talking about methane, we go into a bit more about how methane is created. And my one issue is I might reorganize the paragraphs. I think I'd like to start off with the geological and then end with the living organisms, because I think that's more exciting. And especially that's a prime motivation behind the project too. It's that we want to try and like look for past or present life, right? So there's no point mentioning that and be like, oh yeah, it could also be geological, because realistically it probably is geological. Like especially in Nili Fosse, where there is a lot of serpentinite rock and there's a lot of olivine present. So I think swap the order might be a good play here. Let's not worry about too much with that. So then what's next? I'm almost thinking maybe I should put the methane sections right up here. So just mention the fact that there is methane on Mars, and then mention the fact that there is a discrepancy between the two. Yeah, I like that. So you mentioned there's methane there. You mentioned what the implications of the presence of methane actually is. There could be some life there. And then we talk about how we're struggling to get reliable results because of like there's different results coming in from satellites versus rovers, and that's where the balloon comes in. So I think that's the order of it. But it doesn't matter. Let's just get the words down first, and then we can organize it back then. I think that's the play. So I'll just keep on rolling with this. So the next thing I want to start talking about is I need a nice segue into talking about aircraft on Mars. I kind of did that a little bit when I talked about Ingenuity up here. So that's another reason why I think this should be at the end. So the interest in flight missions to explore Mars arises due to the realization that rovers and satellites working in tandem do not provide comprehensive coverage of both the landscape and atmosphere of Mars. So what does that infer? That means that, or well, we've already mentioned what it infers. There's interest in flight missions because of it. So I think now it's natural to talk a little bit about the history of research in that area. So how do I start this? So planetary exploration through use of aircraft is not is a research topic. Okay, so yeah, what I'd like to say here is that it dates back to X, but that the research I've only looked at really goes from the 90s on. Primarily the use of balloons. The only flight mission to taken place on another planet thus far. Is this true? I don't know if this is true or not. I'm just gonna say it, and then I'll make a note after to confirm this is true, but I think it might be. The only flight mission to have taken place on another planet thus far is the Vega mission, which took place, which explored the Venusian atmosphere. I love that word so much. Atmosphere. Planetary exploration through use of aircraft is a research topic, primarily the use of balloons. The only flight mission to have taken place on another planet thus far is the Vega mission, which explored the Venusian atmosphere. So I kind of incorrect because now you have ingenuity, but I can wordle around better later on. I just want to get the words down. And Vega is also, yeah, so let's check the Google Doc, because I have a lot of stuff on Vega. This is a paper sorted by focus. Alright, let's see. Other planets of Venus, here we go. Robotic exploration of the surface atmosphere of Venus, investigation of the application of aerobot technology. I think this paper is Vega, so let's go with it. By MS Gilmore. So I don't have Google Scholar, I thought I did. Google Scholar. Yeah, this paper is what I'm looking at. So, is this Vega? No, it's Bev and Viffer. Surely it mentions Vega, right? I know what to do. I've made notes on all these papers already. Vega. Okay. So this is talking about the inflation system. Don't care too much. Down. So just that this just says that they mentioned Vega. Down again. There. Major progress in planetary airobot technologies by our boy Viktor Kurzhanovich. Vega is the first and only time balloons have been developed in the Venus atmosphere, and then goes on about Mars. But I'm pretty sure this paper goes more in depth into Venus, but I think I just ignored it. So I'm actually going to check this one out. What am I doing? Google Scholar again. Alright, check it out. Oh, don't tell me I'm having trouble getting into this now. Come on. Okay, I'm in. Okay, so I'm gonna quickly mention that Venus is dope, basically. The reason for this is due to Venus being in close proximity to Earth and its atmosphere being ideal for exploration via planetary balloons. Now, why? So, why is Venus good for balloons? Scientists hope to learn more about climate changes here on Earth by studying Venus. A prototype balloon could eventually study the planet's surface and examine its atmosphere and the bizarre winds and the chemistry within it. Long sentence. A team of JPL, Dover, and Wallops Flight Facility engineers designed, fabricated, and tested the balloon. Blah 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 blah. So first of all, Vega is not capitalized. Let me get rid of that. I just want to know why Venus is ideal. Oh, I guess the textbook could tell me. Yeah, so I have a textbook downloaded. I don't know why I didn't just check that. I'll get that up now. Where is it? Chapter 6, yeah. Open with, get Chrome going, yeah. Nice. Okay. So it should have the answer in here somewhere. Closest and easiest planet for aerobots. That's all it's saying. I just want a sentence to say why Venus is so good for balloon studies. Balloon ascent from the surface is essential for a Venus surface sample return mission. Okay. Because I from my understanding, I thought Venus was like the best one, like the best planet of all the ones to incorporate balloon studies. I can't really see a reason as to why it is. Yeah, I guess it's to do with physics behind it, but they haven't really given me a short sentence. Okay, here we go. So first of all, I say they all have very different environments, which is right. The atmosphere of Venus exhibits extreme atmospheric parameters. The high temperature and pressure in the lower atmosphere strongly limit the lifetime of surface and near-surface vehicles. Without nuclear-powered driven refrigerators or high-temperature electronics, the lifetime would be 2 to 3 hours. High-temperature materials with good gas barrier and strength properties are needed for near-surface LTA vehicles. LTA, lighter than air. On the other hand, the environment of the higher troposphere is quite mild and comparable with the troposphere of the Earth. This region is the most favorable for aerobot missions. Okay. So let's just say that. Where am I? One note. Okay. The troposphere of Venus, or well, the higher. The higher troposphere of Venus is comparable with the troposphere of Earth, which makes testing prototypes much easier, I guess. Which is a really, really important point, you know. We're able to learn more through testing stuff out on Earth. So here I'm going to say reference textbook. Similarly, to introduce an aerobot to the Martian atmosphere would be similar to introduce an aerobot to the Martian atmosphere would be similar to the use of an aerobot. No, I can say this better. Let's go back. The atmospheric properties of the lower Martian atmosphere are similar to that of the properties of Earth's atmosphere at an altitude of, I think it's 34 kilometers. What did I say? 34? Yeah. No, just in case I forget to take it. I did that before. I put in so many stupid like little sentences and words. So like just in case I send this to my supervisor and I have like references shit. Let's just keep it chill. Get some water. Back in a second. Okay. We're making good headway, but I'm gonna have to condense this so much, to be honest. I think I envisioned only like maybe 900 words for the little review, and I think already we're at like 500. I haven't even got onto super pressure balloons yet. So I think instead of going too deep into Montgolfier and solar, I might just group them all. I literally one paragraph. I'm gonna say there are different types of aerobots you can have. Like I mentioned the winged ones, like the drones, planes, helicopters, things like that. And then I mentioned the solar powered ones, and say that like a big issue with the planes tend to be and the helicopters. You have to land and take them off too, and that's very technical and it's very tough to properly explore that, I guess, on Earth, which is why Venus is used for like a testing, or not testing ground. It's why the Vega missions went ahead in the 80s, you know? They were able to test the balloons out on Earth in like similar conditions. But there's nowhere you can really test landing and deploying in similar conditions as Mars. Like, you need like very expensive testing halls, I guess. I don't have that, basically. So I'll just mention that in a paragraph and say the primary reason that super pressure balloons are ideal is that they have a longer mission duration. They can be up there for 100 days. 100 days is chilling, just moving around. So, and then I'll have maybe like 200 to 300 words I can talk about super pressure balloons and the research that's been done so far. And I think that's a nice segue then to get into the actual work then. So trying to figure out, okay, what time of year is it like most suited to actually launch this mission from Earth, in terms of making sure the atmospheric properties are like going to be spot on average. What else? I can start talking about like a bit of thermal analysis. That'll all be next week. And there's one more thing I could do as well. I think it's probably I can put in the work I've done so far choosing what location, because that's done based on where the methane is, but also what conditions are well suited for a balloon to travel in. But let's just work ahead of that for time being. Okay. So where is my OneNote? Here we are. Okay, so what have I got here? The atmospheric properties of the lower Martian atmosphere are similar to that of the properties of Earth's atmosphere at an altitude of 45k. Okay. This makes it easy, or not easy, an ideal candidate to develop an aerobot mission, as it will not be purely theoretical, and there is an ideal, or there is an appropriate testing grounds here on Earth to iterate prototypes and arrive at an ideal solution. Okay. So, what is an aerobot? Let's look this up. Aerobot. An aerobot is an aerial robot. Thank you so much. Usually used in the context of an unmanned space probe or unmanned aerial vehicle. While work has been done in the 1960s on robot rovers, So I should change to aerobots. I just want to make sure that my words are kind of precise here, because if I say aerobot too much, then it would look a bit weird to just introduce winged aircraft, because there's distinction. Aerobots are specifically inflatable. So I want to make sure I'm using aircraft throughout and then introduce aerobot towards the end. So let's just read through this. Planetary exploration through the use of aircraft is a research topic, primarily the use of aerobots. And then I can reference the Mars aerobot and the Venus Vega balloons here. And also, yeah, I can just reference a fuckload there. Sometimes papers say a sentence and then they have like 12 references after it without really going into them. I think this is going to be a lit review where I have to do that, because I'm kind of constrained by the amount of words I can use. Okay, so the only flight missions to have taken place on another planet thus far is the Vega mission, which explored the Venusian atmosphere. The reason for this is due to Venus being in close proximity to Earth and its atmosphere being ideal for exploration via planetary balloons. The higher troposphere of Venus, I'm going to say the upper, the upper troposphere of Venus is comparable with the troposphere of Earth, which makes testing prototypes much easier. The atmospheric properties of the lower Martian atmosphere are similar to that, maybe also, but yeah, are similar to that of the properties of Earth's atmosphere at an altitude of 45k. This makes it an ideal candidate to develop an aerobot mission, as it will not be purely theoretical, and there is an appropriate testing ground here on Earth to iterate prototypes and arrive at an ideal solution. So, to make okay, I'll leave it here for now, but yeah. Okay, so an aircraft mission to another planet can make use of a number of different aircraft. So winged including planes, drones, so I'll say planes, drones, and helicopters are constrained due to their need to I need to be very careful with how I word this. Planes, drones, and helicopters are constrained in their missions due to their need to land and deploy. Between objectives and for recharging or refueling purposes. References. This raises the question to whether or not the use of aerobots are ideal for planetary exploration. Solar balloons and Montgolfier balloons. Fact check this, make sure this makes sense, dude. Just because I don't know if Montgolfier balloons are a subset of solar balloons, in which case I'd have to change around my wording just a small bit. Okay. Are not ideal candidates as they are constrained in their overall mission time. A solar balloon can only explore for the daytime, and once it loses its heat source, the sun, it must land, and use of a deployment system and takeoff system must be incorporated to attempt subsequent missions. Again, like, my wording is so off. Some of these sentences are far too long, some of them are too short, some of them don't make sense. But all I'm trying to do is just build a story. Let's go up to the end here. Goal. This is the main thing. Build a story. I don't care if it doesn't make sense too much. I just want to make sure I'm like going in the right steps to where I want to end up. And then once I've done that, it's going to be so much easier to go back through it all and to kind of reword certain parts. Bum 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 bum. Okay, let's check ourselves here. How are we getting on? A solar balloon can only explore for the daytime, and once it loses its heat source, it must land, and use of a deployment and takeoff system must be incorporated to attempt subsequent missions. Okay, dope. So now this is where I start going into super pressure balloons, I think. The real meat. Note to self, check out proper report writing technique. Be sure. Nothing worse than like having good shit written down but you leave marks on like small things like that, you know? and it's so easy to make sure you're doing right. So I just want to. Alright. I think I also want to say with not helicopters, but with planes, you can't hover over one area of interest. You have to always be on the move, and that's why balloons are kind of ideal, because you can just go somewhere, you can just chill and just investigate it for a while. So that's why balloons are kind of cool. So I think I want to do like a sentence here as to why balloons are dope. Balloons are advantageous for planetary exploration due to the relatively inexpensive cost, lightweight, easier storage, and ability to hover over an area of interest. I think that's all I need to say. Let's not get too deep into it. Oh, I like this. I like this. And this is actually how Perseverance landed too. So you, rather than having to have a good communication system on your gondola, you can instead make use of communication systems that are like very advanced on nearby satellites. So if you have a relatively weak or inexpensive communication system on the gondola, you can point your antennas at a nearby satellite, and if they're also pointing at the gondola, they can get the limited information as opposed to sending it directly from the balloon, which would mean that more of the weight on the balloon would have to be in the form of a communication payload, which is not what you want. The whole point of this is to try and they haven't mentioned super pressure balloons at all, so maybe they're going to mention it in the Mars section. I just want to see how many words now. Bearing in mind that I can probably eliminate about 100, no less. It's probably like enter. If this is already above 800, I'm kind of fucked. Wait, what? Oh, that's something else. Okay. Okay. I mean, 860 words is what I said was like a good proportion to aim for. But I think I could probably push it to about 900, which will be needed for sure. Okay, so this page, I thought it. I was under the impression that a Montgolfier had to land during the daytime. They're saying here it spent 69 days aloft. 69, nice, huh? Oh fuck, I thought it was just a day-to-day. Montgolfier night time. So this is Control F night. Okay, this is all he. Okay, this is what I want to look at. The Montgolfier. A fifth type of balloon is known as an infrared Montgolfier and flies in the Earth's cold stratosphere by heating from the sun during the day and trapping lower Earth planetary radiation at night. The French have flown over 40 such balloons since the 1970s, the longest of which lasted 69 days and encircled the Earth twice. These balloons generally have a fixed daytime altitude and a fixed nighttime altitude. So is the idea that you just trap enough heat that it keeps you up? What I think it is. I think that's what it is, to be honest. And maybe that won't work on Mars because you just wouldn't be able to trap enough heat, I imagine. So, yeah. A novel combination of two of these buoyancy concepts have been proposed for Earth ultra-long duration balloons. So yeah, this is the combination of your super pressure balloon up here, and down here is your Montgolfier. So they're kind of in tandem together. Observatories. In addition, helium balloons systems are not well suited to provide adequate altitude control to catch favorable winds for relocation or to land in specific areas. Altitude control for helium balloons previously required the limited use of venting and or ballasting. Recently, JPL have proposed to use a lightweight zero pressure, so that's the same pressure inside and out, a helium balloon to provide most of the lift during the day due to nighttime cooling of the helium balloon, and to push the balloon system higher if desired. A vent in the top of the infrared Montgolfier can vary buoyancy, and testing is underway to confirm if this novel balloon combination can replace present super pressure ultra long duration balloons. That's a cool idea. Because I've always thought the Montgolfier, but I can see how one kind of brings out the strengths in the other a little bit. Like it's not able to adapt its. I just thought that I thought at nighttime the Montgolfier would just not work. Wow. Okay. Alright, I'm gonna have my tea break now. I'm back in like 10 minutes or so. Watch a video and then get back into work. I should get the lit review done today, and that'll be real nice. That'd be really nice.
a controversial security law in Hong Kong, building in the South China Sea, to China's global infrastructure projects, there is undeniably a Cold War-like battle for influence on all fronts. And that includes space.
We're in a space race today, just as we were in the 1960s. And the stakes are even higher.
Although China hasn't come close to achieving what the US has, they're catching up. Since 2018, China has launched more rockets into orbit than any other country. In 2019, they became the first to land a rover on the far side of the moon. And in 2020, China released the last satellite in their global navigation satellite system, called Beidou, China's answer to the US-made GPS. Like China's big infrastructure projects here on Earth, their goals are to get a foothold in space technology that will drive profit, make them independent from US technology, get an upper hand in military operations, and show superiority on the world stage. With Joe Biden in the White House, experts think space spending could slow, although the Democratic Party has stated that it will continue the goal of sending Americans back to the moon and beyond to Mars.
We are launching humans to the moon for the first time since 1972.
And that might not be a bad thing. While a Cold War scenario has dangerous political and economic implications to Mars.
We are launching humans to the moon for the first time since 1972.
And that might not be a bad thing. While a Cold War scenario has dangerous political and economic implications, a race to the cosmos, like any good rivalry, could be a huge benefit for space and other industries.
If you think that the US-China competition is going to be not just a clash of strategies, but a clash of systems, it's going to be a contest over whether American-style liberal democracy or Chinese-style authoritarian capitalism is best suited to the demands of the 21st century, then it's entirely possible that you could see the United States make investments in infrastructure and education and technological innovation and basic research that it wouldn't otherwise make as a result of that competition.
In 1957, the Soviet Union shocked the world by putting the first ever satellite into space, Sputnik 1.
There is real military significance to these launchings.
The satellite's unanticipated success brought on the American Sputnik crisis, a period of public fear and anxiety in Western nations about the perceived technological gap between the United States and Soviet Union.
And so the National Defense Education Act of 1957 is passed in response to Sputnik, and it includes major investments in a variety of intellectual pursuits that were considered critical to staying ahead in the Cold War. And so the rise of entire industries like aerospace, the rise of entire regions like Silicon Valley or Orange County, semiconductors, the internet, a variety of other things that we associate with the rise of the information age were originally conceived as part of the military-industrial complex in the 1950s and 1960s.
And let me say that our scientists and engineers, in offering their service to the government in this field, have been generous, patriotic, and prompt.
And nowhere was government spending more apparent and highly publicized as the space race of the time.
In the Eisenhower years and then Kennedy years, the U.S. started pouring money into the space program by, I think, mid-1960s, the U.S. was spending about 4% of its total budget on space.
It was the largest percentage of the budget spent on space in American history. And the intense rivalry allowed for some of the biggest accomplishments humanity has ever seen, including the first living animal to enter space by Russia, the first man to enter space by Russia, and the first probe to land on the moon, also Russia.
And so that led to a huge surge in U.S. spending on the space program, which culminated in 1969 with Neil Armstrong and Buzz Aldrin stepping on the moon.
The moon landing is considered a conclusion to the space race, and as US-Soviet relations improved, space spending waned.
I think that one of the reasons that the U.S. has not been as focused on space is because of the end of the Cold War.
Since the Apollo program, the NASA budget has hovered around 0.5 to 1%. But in the last few decades, the world has seen the rise of a new power, China. While governed by an authoritarian regime like the USSR was, China also has far more economic strength and greater resources than the Soviet Union ever did. And that worries the US.
The president has already signed into law the largest NASA budget since the days of the Apollo program.
There is very much an ideological challenge. It's sort of a contest over which sort of system, democracy or authoritarian capitalism, will win the day in the 21st century. And I think what American officials fear is that the Chinese will not be content to have second-tier status in a world that is led by the United States and its allies.
But space isn't simply a show of technological strength like it was during the Cold War. The space industry is now worth an estimated $345 billion, with technology that we use every day depending on it, like GPS. China started launching an alternative to the American system called Beidou in 2000. The recently completed version is 20 centimeters more accurate than GPS by some estimates.
China's Beidou space program brings prestige and practical benefits. The prestige from announcing their arrival as a power in space, similar to the prestige which the US achieved from its first moon landing. The practical benefits, both military and commercial. If you want to target a missile or a fast food delivery, you need a GPS system. With its Beidou system, China has its own GPS capability in place, and so independence from US influence on that key part of infrastructure in the information economy.
China even opened up the private space industry in 2014 in the hope of encouraging competitors to the US private space industry. iSpace was the first private company in China to successfully launch a rocket and satellite into orbit in 2019. And a company called Galaxy Space plans to launch 650 low Earth orbit satellites similar to SpaceX's Starlink, which will give better, faster internet access to people all over the world. But it's not all about business.
I think that for President Xi Jinping, this Chinese space program is hugely important, not just for all the practical applications, but also just for prestige. It's important for President Xi to show that China is a superpower. Superpowers have space programs.
China will have to prove that they can perform the kind of missions NASA has done, and possibly go even further, like China's recent moon rover, Chang'e 4. Although it was the third country to land a rover on the moon, it was the first to land on the far side of the moon. And China's recently launched Mars rover isn't the first, but it's the first orbiter lander rover all-in-one mission. China even has a Voyager-like mission in its initial planning stages that will do a flyby of Neptune and then out to explore interstellar space. But more importantly, China will build its own space station, which will serve as an essential tool for tests and research in space, and offer an alternative to the International Space Station.
When it comes to innovation, China will have some advantages when it comes to directing the entire resources of a state or the entire resources of a society towards some particular technological challenge, AI for instance. But the cost of that is that there's less of an open economic and intellectual ecosystem in China than there is in the United States. There's more inherent dynamism in a society where you have truly open information flows and where innovation is as much a bottom-up as it is a top-down phenomenon. And so that's not to say that the United States is destined to win the race for AI or 5G or any other technology. I think there's real danger in a lot of these fields. But if the United States puts forth the energy and puts forth the investment that's necessary in these areas, there's no inherent reason that it can't succeed because it is a democracy.
And there are signs that China's space program is stumbling. In 2020, a Long March 5B rocket scattered debris over Côte d'Ivoire after an uncontrolled re-entry of the rocket's core stage. This was the largest botch of its kind in years.
So the worry is that China is just not that transparent when it comes to this sort of thing. So was this just a one-off? Was this just something went wrong? Or is this just an example of what might be happening going forward?
The competition may prove to be too much. China is up against not only a space program with a long and decorated history, but one with more ambitious missions than ever before. The US is now trying to beat China back to the moon to build a lunar base, harvest resources, and then use it as a stepping stone to get to Mars.
This time when we go to the moon, we're going to go to stay with a purpose of learning how to live and work on another world so that we can take that knowledge and information to Mars.
I think that the sense of urgency that we're hearing from the Trump administration about the need to accelerate the Artemis program to get to the moon by 2024, I think part of that is because of the perceived threat from China, right? So in that sense, I think that having China as a more serious player in space could potentially be good for NASA, good for the American space program.
Other NASA projects include a Mars mission equipped with a mini helicopter to fly on the surface of the red planet, another mini helicopter mission planned for Titan, Saturn's largest moon, and the launch of the James Webb Space Telescope, an upgrade to the Hubble Space Telescope, whose photographs changed our understanding of the universe as we know it. The ambitions of China and the US may depend on how long their rivalry continues. If history is any lesson, the bigger the rivalry, the further the two space superpowers are likely to push themselves.
Very cohesive.
The overall goal with China's space program, I think, is to match the United States. China does not want to be subordinate to the US on Earth and doesn't want to be subordinate to the US in space. Right now, the plan is to try to narrow the gap.
And so if you are looking at this from an American strategic perspective, the concern would be that China may have a jump in the areas of high-tech innovation that will be most important in terms of powering innovation and productivity during the 21st century, and that can perhaps be turned into advantages on the battlefield. I should say that the jury is really still out in terms of how effective China will be in mastering innovation in these areas. But if China continues to lack the open informational ecosystem that we've typically associated with success and innovation, there may still be significant obstacles to maintaining the dynamism needed to spur innovation over the long run.
a person can endlessly stare at three things: a burning fire, running water, and other people working. I propose adding one more item: bewitching photos of space taken by the Hubble Space Telescope. This automatic observatory the size of a school bus has discovered millions of new objects. Thanks to the Hubble Space Telescope, we've witnessed the birth of new stars, found planets outside the solar system, and seen supermassive black holes. If you somehow missed any of it or managed to forget, today's video will fix that. The Hubble Space Telescope is the most famous telescope in the world. It received its name in honor of the famous astronomer Edwin Hubble. This scientist changed our understanding of the universe, proving the existence of other galaxies. It was assumed that the Hubble Space Telescope would operate in low Earth orbit for 15 years. But April 24th, 2020 marked exactly 30 years since it started unraveling the secrets of the universe. So, the first photo is a triple solar eclipse on Jupiter. This planet has at least 79 moons. Two of them, Ganymede and Io, were captured in a unique image at the same time. Callisto is located outside the photo on the right. All of them cast a shadow on the surface of Jupiter. Scientists have observed such a phenomenon only twice in 15 years. Jupiter often falls into Hubble's lenses. This time-lapse shows the movements of the auroras on the planet. The photos were taken in the far ultraviolet range. The diameter of the area where the glow appears is larger than the diameter of the Earth. Like on Earth, auroras on Jupiter arise due to solar wind, whose particles collide with gas molecules, mainly hydrogen, and transfer energy to it. Particle streams from 3 of its moons also contribute to it. Since the magnetic field of Jupiter is more powerful than that of the Earth, the radiance here is several times brighter. And while on our planet auroras occur during periods of solar activity, on Jupiter they shine continuously. This here is a photograph of Mars taken by Hubble in May 2016. At this time, the red planet approached the Earth at a relatively close distance, 80 million kilometers or 50 million miles. Volcanoes, craters, and plains are clearly visible in the photo. In the center of the picture, you can see the Arabia Terra, an extensive hill that occupies about 4,500 kilometers or 2,796 miles. On the right side is the Syrtis Major Planum Plateau, and to the south, the plain of Hella Planitia. Also, in the picture, you can see the movement of clouds and polar caps at the poles. Now, what does this photo look like? It's reminiscent of the Eye of Sauron from The Lord of the Rings, right? This is one of the brightest stars in the night sky, Fomalhaut, a giant that is 2.3 times heavier and 6 times brighter than the sun. Around it is a disk of cosmic dust, which creates the resemblance of an ominous eye. But photography is interesting not only for this reason. See that tiny orange dot? This is a planet outside the solar system. It was originally called Fomalhaut B, but astronomers then started calling it the zombie planet. The fact is that in 2008, after the publication of this photo, scientists recognized Fomalhaut B as a planet, but then changed their minds and began seeing it as just a cloud of dust. Thanks to new observations in 2011, Fomalhaut B was resurrected, ranked among the planets, and even given a different name, Dagon. But in April 2020, astronomers again began doubting its existence. In new Hubble pictures, the planet is gone. Scientists believe that Dagon was a cloud of dust and debris formed as a result of a collision of 2 icy celestial bodies. And over time, it dispersed. Now, we've transported to the constellation Centaurus. Inside is the Omega Centauri, a globular cluster of stars. It's located 15,800 light-years from Earth and contains almost 10 million stars. Usually, stars in globular clusters form simultaneously, but the stars in Omega Centauri are at different stages of development. Most of the stars in the photo, like our sun, are yellow and white. There are several red giants as well as blue stragglers. Omega Centauri is the largest globular cluster in the Milky Way. It can be seen in the sky with the naked eye. In this video of a stretch of the starry sky, even closer is the constellation Cygnus, and even closer than that is the Veil Nebula, an amazingly beautiful object. It formed as a result of a supernova explosion about 8,000 years ago. It's estimated that this star was 20 times more massive than the Sun. These multicolored fibers of gas, compressed by a shock wave, are its only remnants. The colored cloud of the nebula extends for approximately 110 light years. When observed from Earth, its apparent size occupies an area 6 times the diameter of a full moon. It's so large that its parts are considered separate nebulae. This video was created from a series of photos taken by Hubble over the course of 9 months. In them is the Crab Nebula in the constellation Taurus. At its center is a pulsar, a relatively young neutron star with a very small diameter, 28 to 30 kilometers, or about 17 to 19 miles. This is all that remains after a supernova explosion. The pulsar rotates around its axis at a frantic speed of 30 revolutions per second, which generates a strong magnetic field and powerful radiation fluxes. In the video, they look like waves. Here is another nebula, this time in the constellation Orion. The Horsehead Nebula is dark, consisting of very dense clouds of gas and dust that absorb visible light from other stars. The outlines of the dark Horsehead Nebula stand out against a red background. Hydrogen clouds glow under the influence of radiation from the nearest bright star, Alnitak. New stars are constantly being born in the nebula. Some of them can be seen at the base of the head. In this image is the Bubble Nebula. At its center is a hot and massive star, creating powerful gas flows. These stellar winds eventually pushed out the gas and dust over time, resulting in the nebula's intricate fibrous structures. Astronomers suggest that in 10 to 20 million years, the star will explode as a supernova, and then the bubble will suffer the fate of all bubbles. It will burst. Thanks to the Hubble, we can take a virtual tour of another galaxy. This 3D image shows the Whirlpool Galaxy in the constellation Canis Venatici. It looks like a spiral staircase. This is one of the closest spiral galaxies to the Earth, sitting at about 23 million light years away. The arms of the galaxy are almost perfectly symmetrical. Flying over the galaxy, you can see that in the center there are older yellow stars, and on the edges, young blue stars. You may not have known, but Hubble holds the record for the longest range of observation. Before you now is the constellation Ursa Major, and in its direction is the farthest away of all known galaxies. It's located 13.4 billion light years away from us.
That's
the
the
light
furthest
from this
away.
galaxy has just reached the Earth, crossing the distance that separates us. That is, now we can observe it as it was 400 million years after the Big Bang. This galaxy is 25 times smaller than ours, the Milky Way. Previously, the farthest galaxy was considered to be 13.1 billion light years away from Earth. Hubble watches not only for relatively motionless stars and galaxies, but also for fast-moving objects. For example, it was able to catch the comet 2I Borisov. It was flying at more than 175,000 kilometers or 109,000 miles an hour, approximately 420 million kilometers or 261 million miles from the Earth. This time-lapse shows a 7-hour observation of the comet on October 12, 2019. In the image, you can see the central part of the comet consisting of dust and gas. It looks like a luminous blue cloud. The streaks of light passing by are the stars that fell into the frame while Hubble was capturing the comet. By the way, it didn't come from our solar system. 2I Borisov became the second known interstellar object to pass through our solar system. During its work, Hubble has presented millions of images of space to mankind.
That's insane.
But unfortunately,
It looks so
the
cool.
days of the Space Observatory in orbit are numbered.
Yeah.
NASA has
James
suspended
Webb
missions
incoming.
to repair and modernize the telescope. It's assumed that in 2021, Hubble will be replaced by the new James Webb Space Telescope.
I wonder if it's still
If you like this
next
video,
year
give
or
it a
this year,
thumbs
right?
up.
We're
Don't
2021 now.
forget to subscribe to the channel and click on the bell to receive notifications of new videos.
I wonder if it's still 2021 that they're expecting to come in. I like this dude. I'm gonna subscribe. This is before we get working again. I just want to look this up. So James Webb Telescope. Let's see. No, it doesn't say it here. Surely Wikipedia has it. Oh, launch date, yeah, 31st of October 2021. My dad's birthday. That's pretty sick. It looks pretty funky, doesn't it? I don't even know what's going on here. It's like you have different layers. What? Like the Hubble Space Telescope, you could tell that was a camera or something because I don't know, it was round and pointed somewhere. But here it's a bit odd. I've never seen any camera like this before. How big is it? Because Hubble is, they said, the size of a school bus. This is 20 by 14 meters. Yeah, about the same. Or is it about the same? I don't know. We have 20 by 14 here. And in Hubble we have 13 by 4. So yeah, bigger boy. But I mean, you'd have a hard time convincing me that this is smaller than this. I don't know. Just based on those two pictures, I'd be having a big argument with you, like, straight up. What orbit is it going to be in? A halo orbit? Yeah, these orbits are interesting. So it's actually, it's going around the Earth, but it's like offset. And it's offset by these, they're called L shells, where L1, so I think this is L2. So L2 means that it's 2 Earth radiuses away from Earth. But although in this picture it looks like it's a fuckload away, doesn't it? I guess, oh sorry, yeah, this picture isn't saying L2. But I wonder, I'd say that's like, I don't know, L15 or something. We click in. It doesn't say. It doesn't say what L it is. Maybe it's not to scale. Who knows? Yeah, pretty sick. Okay. So I'm pretty close to getting. Let's switch back scenes and put on music. I'm pretty close to getting a lit review done again. Okay, so where do we leave off? Okay. This has led to the author to select a super pressure balloon, which has also been researched for exploring Mars previously. Get up also. Okay. Okay. So I just want to do like, I don't know, like maybe a paragraph or two now on super pressure balloons. Just like talking about some of the stuff with them. I want to talk about material choices. I want to talk about a little bit on D&I, small bit I guess. And also the fact that they have longer mission periods. Am I spelling super pressure wrong? No. No, I'm not. can full stop this right here. I think I'm missing something. I feel like I'm missing something here. Material choice. Let me check the document. No, not really. Oh, fabrication techniques. I think that kind of encapsulates it. Okay. there's going to be a fuckload of references backing that up. I think every single paper I've read has at some point mentioned the fact that it's very difficult to model deployment of inflation. Yeah. Oh yeah, research for sure, right? And now I just want a paragraph kind of summarizing what the work will be. Yeah, he's gonna go to the bathroom. So, I think that I have kind of set the story now that I wanted to get out in the first section of the report, and now it's the case I just want to go back over everything, add references where necessary, and do a little bit of rewording, I guess. I'm not fully sure I captured exactly what I wanted to say at the end there. Let's see. Okay. So let's see. Oh, let me check. I have a proposed plan, so let me see what exactly I said here. So section 1, introduction, statement of aims, measurement of methane, brief discussion of methane areas on Mars, which I haven't done yet. Plumes, I haven't done yet. Talk about Lily phosphate briefly, haven't done. Methane and NF, haven't done. Serpentinization, potential storage of CH4 in the subsurface, I have done. Potential ways to characterize the source of the methane detected, I haven't done either. I think I can incorporate that into the second section, which is talk about what I've actually done so far. Work done so far. I feel like selection of an appropriate site to investigate is sufficient to put in work done so far. While everything else I've kind of talked about so far in typing here, that's just more of like observations of what other people have done. So I think it makes sense to put that in the work done so far, along with things like the thermal calculations and also the atmospheric, what am I thinking of? The atmospheric kind of research to see where is good to check out, but also what time of year to go at. So I think that's all good to put in section 2. So I kind of changed this around as I actually typed it out. Don't know if that's a good thing or a bad thing, but look, we did it anyway, so fuck it. Statement of objectives, why balloons? Talk about satellites and rovers not being able to get the full pictures of sensing. We did that. Talk about winged UAVs, drones, different type of balloons, and reach the conclusion that a super pressure balloon is the way to go. We've done that. equations and derivation of key equations such as del P, subsequent parameters that will be important to optimize. That can be done in work in section 2 as well. Maybe like 200 words where I can talk about the physics behind everything. So yeah, I think for section 1 I just want to tell a good story. That's it. I want to capture attention and just highlight that this is like really, really important and worth checking out. That's it. Let's just check out if I go up here, the requirements. So yeah, section 1 here, a brief introduction to the project, including a brief outline of the envisaged work. Yeah, I think I've done that pretty well. It doesn't say section 1 is like a full lit review or anything. It just says a brief introduction to the project, which I've done. I presented what the problem is and what some of the potential solutions to that problem are. And then I arrived at one conclusion that like we should definitely check this one out. And then a brief outline of the envisaged work. In the last paragraph, I kind of did that, I'd like to say. Let's scroll down. Yeah, so I said here, the aim is to focus on increasing mass efficiency. And then I said that will be achieved through these things. And that's exactly what it's saying here. A brief outline of the envisaged work. While I'm not going into detail about what I'm doing, I'm kind of saying what I'll be trying to figure out. I think that's sufficient. So how's it marked? Let's see. Amount of actual research work that the student has carried out, and any preliminary conclusions reached. So let me see. What conclusions will we have reached? I think there's definitely going to be 2. One is, oh, maybe 3. One will be whether to use hydrogen or helium, and I think that can be done pretty easily. That'll be done in tandem with the second thing we can figure out, which is where is the best place to check out. And that's just done by checking out the database and seeing what properties align with the physics needed for an effective balloon mission to take place. And then the other thing we can check out too and have a conclusion of is when during the year is the best time for a mission to take place. So how that'll be figured out is, again, going to the database, checking out the parameters and seeing, okay, we know that roughly these atmospheric properties are what we'd like to have. We can find out when on average that period would be, and then working backwards we can figure out, okay, when is the best time to launch from Earth. I think it's like an 8-month period it takes to get there, so it's just trying to figure out that timeline, go back 8 months and say launch from then. I think that's like 3 good conclusions we can get from preliminary work. And also just like the conclusion that we're going to go with a super pressure balloon too, I guess. That's like 4 or 5 already. And also, like with the amount of references I'll have too, it shows a good amount of research done. So I'm happy enough to do well here. Second, should reflect how well the student has grasped the aim of the project and has tackled the initial literature review during the first weeks of the project work. Okay, yeah. How do I get that into the report itself? I think I just need to keep on referring back to trying to increase the mass efficiency parameter. And if I do that throughout, I think I'll be fine. Fingers crossed. And has tackled the initial literature review during the first weeks of the project work. I think that's just showing that you've gone back through some papers and showing some conclusions from those papers, which I can do very easily as well. And then the last thing, expect to contain a summary of the work still to do, update project schedule, and a provisional contents list for the final report. That's all fine. Okay, so let's see how many words we have. Bearing in mind that there's probably about 50 to 70 words in like chain brackets that we can get rid of. So, copy. I imagine this is probably close to 1,000, not more. Yeah, just over 1,000. So take away like 50. Yeah, about kind of 960. So we're about 100 words over. If you get 10% of 860 and add it on, not too hot. We're a little bit over. We're a little bit over the plus or minus 10%. And also bearing in mind that the 3,000 words is like a hard like cap. So I reckon I will just change around the referencing and just put it straight in and just leave it at that for now. And when I've done the work to do, or sorry, when I've done the next 2 sections, I can see if I'm like way past the 3k word limit, and I can just cut stuff out. Because realistically, this section is like worth the least amount of marks. Let me see. 20 marks. Okay, no, so it's worth a bit more than the last section. But this is what I mean, like this is why I have to be careful. 30 marks for presentation, literary style, and organization. That's hefty. That's absolutely hefty. I'm actually gonna just message my supervisor and be like, look, I need a bit of guidance here because that's so many fucking marks. So yeah, let's see. Teams. Alright, bet. Okay, so let's just go back through the OneNote. I'm gonna put it over here for now. It actually fits nicely. It actually fits quite nicely here. Okay, so let's see how the story goes. Because first I'd like to reorganize it a bit, and then once I have it in the right, order, I think I'd like to change it then. So, okay, so I start off with talking about the rover and satellite and how there's a kind of black region in between them where we're not able to get reliable results on the things we're looking for. And that's where we present the idea of a balloon. Can I make this wider? Yeah, I can. Okay. So yeah, I talk about how there's rover and satellite, but now recently there's been interest in flying space missions. And why is this? Why are they deciding to look into flying? because of the kind of black spot where their satellites and rovers are not able to get good results, reliable results. And that's what I talk about here. Then this is talking about like specifically like an area that showed that there was a discrepancy in the readings. Not that it's just like some theoretical like, you know, maybe it's not going to be able to. This is literal evidence that like it's not able to, which is important to include. So yeah, I hate this sentence I wrote. I might just change it. I'll do the organization first and then go on to wording. But look at this sentence. There is a clear discrepancy between instruments which are measuring the same thing but are located at different altitudes when trying to provide data on CH4 in the same location of the lower atmosphere. I don't know what I'm trying to say there. I think I had like 4 ideas and then I just tried to put them all in one sentence. But I can work on that. Okay, so do you know, I said earlier on I kind of wanted to change the order of these paragraphs, but I actually like this because it's not going straight into the meaty subject of it. Like, it's just a kind of something that just makes sense to start off, you know? Nothing too flowery. So I say what's happening at the moment. I present the problem with what's happening at the moment. And then I explain, because of that problem, we can do something to fix it. That's basically what these beginning paragraphs are saying. Okay, cool. So let's go into what it is that we're looking to measure, methane. So we talk about methane here. The implication that on Earth, if you see methane, it probably came from a living organism, is what we're saying here. So that means if you apply the same logic to Mars, can you do that first of all? And if you do, there's a good chance that you can either discover extinct life or life that's still there chilling somewhere in the subsurface. So yeah, at the end of this paragraph then, I'm saying, okay, cool. What's that other 10%, you know? Like on Earth, is it just down to living organisms? No, it's not. It says 90%. So where's the other 10% going? And on Mars, that could be a different weighting as well. So we say here there are a couple of ideas. So I said first it could be biological, and that could be either from extinct or still living. If it was extinct, it's methane. Because I said here 300 to 600 years, you'd expect it to stay. If it was extinct from, let's say, 2,000 years ago or more, that methane is like stuck beneath rocks, which I mentioned here. And then it's like able to like seep up through the pores and then come out into the atmosphere. And then alternatively, it could just be from living organisms that are just like kind of letting that methane out, like periodically, I guess, or whatever. Not really much more to go on there. And then also it could be geological, and then that's called serpentinization. And there was no need to go deep into serpentinization. I can do that in my actual report. I don't think it's necessary to do right here. I'll do the equation, but I don't think there's any need to go into the deep stuff about it at all. Okay, so we've talked about methane. So now let's revisit the issue we brought up earlier on. Okay, we're gonna use aircraft to check out these methane plumes. So I'm actually gonna maybe brief paragraph on why aircraft would be good to investigate this methane stuff. Just because I feel like the way I've had it so far, I've presented the problem and then I've gone into the problem a little bit more in detail. And I also briefly presented the solution earlier on, but then I'm just going back to the solution kind of without a good segue. So I think it might be necessary just to kind of be a bit more smooth in going there, which is why I think this little paragraph could be good. So yeah, we go to planetary exploration. We say that the Vega missions about Venus. Why Venus? Why not a different planet? And then we say the reason that Venus is chosen is also applicable to why Mars would be a good place to use aircraft or aerobots. So okay, cool. We've decided that Mars is good for aerobots or aircraft. Okay, let's do it. But wait a second, what aircraft do you use? And that's what we're talking about here. Basically saying that look, you can use planes, you can use drones, you can use balloons, blah blah blah. Very briefly say why the other ones are bad, and then I explain why to go with balloons. Okay, let's go for balloons. But wait a second, can't you use different types of balloons? Yes, you can. And that's what this section is going through then. Basically saying, okay, look, what about this balloon? What about this balloon? No, let's not go with these because of these reasons. And then arriving at the solution that let's go with a super pressure balloon. So this is here. So then very briefly going into a little bit of detail about a super pressure balloon. What is a super pressure balloon? And then this, so I basically said here that the reason why all these are the reasons behind these being bad is the reason why you choose a super pressure balloon, but I haven't really said that we choose a super pressure balloon for the benefits it provides. So maybe that's something else I can include. So I said here a typical mission length for Mars would be in the region of 100 days. I think a sentence here explaining why that's a good thing is necessary. So I'll do that. The longer mission length is appealing as there is more incentive to fund a mission with a longer duration. For a longer duration, yeah, I think that's fine. I think that gets across the point. Okay, so new paragraph. Okay, we've chosen the super pressure balloon. Cool, let's just go for it. Wait a second. What about like we can do a lot of stuff with a super pressure balloon. We can choose different materials. We can choose what gas is inside it. Let's talk about that for a little bit. So I do talk about that for a little bit. So yeah, what are design considerations? And I start off with saying the main one that this project will be focused on is the mass efficiency parameter. And I haven't explained what that parameter is. I don't know if it's necessary to. That's something I'll have to think about, but I'm just going to keep it like this for now because I don't want to add in too many words. I'm already over the word count by quite a bit. Okay, so how do you improve the mass efficiency parameter? You do it by choosing proper materials for the balloon, your selection of your buoyancy gas, the optimal location for exploration, etc. I feel like this whole section here, I basically just repeat down here. So I'm actually gonna do like notes on intro. Reasons or methods to improve MF are repeated, so maybe just go with one or think of a way to say, or think of a nice way to explain the concepts. Where am I? So I mentioned about the deployment and inflation and like some of the issues that come with that. And then I finish it with just like summarizing, okay, based on all this information and the conclusions we've reached, this is the stuff that we're going to try and do. I'm pretty happy with the route I took to get there. Now it's just a question of making it look nice and putting the references. So I think I'll just do the references now. Get that over and done with. Let's go right back to the beginning. Okay, so Control F, ingenuity. Okay. Okay, yeah, so I actually need to do this in Overleaf, so let's get Overleaf up. Okay. So, a nice way to do citations on Google Scholar, instead of having to type out the whole like reference yourself, if you go to Google Scholar and you see these little quotation marks, it says cite, click on that. You can just copy and paste in these at the bottom of your documents if you wish, depending on whatever you want to do. But in Overleaf, it's nice if you click BibTeX, you copy and paste this, go back to your report, and just put it in there. And then if you ever want to cite in your document, you just type /cite and you put this little tag in there too, and it'll just come up as a reference. So copy, go into introduction. I guess I should put in my stuff first. So where am I? OneNote, copy and paste. Okay, and first off, I'm just gonna go between all the paragraphs and let's go like this. This is the symbol for doing. Oh, here we go. This is what you do for paragraphs in Overleaf. There we go. And now let's do the referencing. So I want to reference that by Ingenuity. Yeah, cite this. So / cite, and we have it here, and there you go. And just to show you, if we compile this again, and now scroll down, our citation is here. So yeah, it looks really awful at the moment, but we're gonna clean that up now. So for this, let's get my abstract out. And down here, we have the references. So let me just see. It should be 1 and 2, I think. So the 0.05 is 1. Okay, so 1, 2, and 3. So I'm gonna put all that in. So 1, 2. And tree. And go back to the abstract one more time. And let's just figure out where those references are used. with my ref. Okay, so reference 1 is after the 0.05. So go back to overleaf. Go into introduction. So 0.05 here. There we go. That's all it is. Simple as. So next, go back to here. I'll stretch my legs for a second.